to Gwinnett County Public Library. My name is Amy Perry, and I'm an adult services specialist here at the library. Thank you for joining our author talk with David George Haskell. David George Haskell is a writer and biologist. His latest book, Sounds Wild and Broken, was selected by the New York Times as an editor's choice. His previous books, The Forest Unseen and The Songs of Trees, are acclaimed for their integration of science, poetry, and the rich attention to the living world. Among their honors include the National Academy's Best Book Award and a finalist for the Pulitzer Prize, among several other accolades. Haskell received his BA from the University of Oxford and his PhD from Cornell University. He is a professor at the University of the South in Sewanee, Tennessee. Please welcome David Haskell.
It's a great pleasure to join you all from, I'm actually right now in the next county over in DeKalb County in Atlanta. I hope to visit in person one of these days. And I'm delighted to join you here through Zoom to talk a little bit about this book, Sounds Wild and Broken. So it's newly out in paperback. It's also available in libraries, of course. And in this book, I want to honor the marvels of sound on planet Earth. Of course, I'm using one of those marvels now, which is the human voice. So human voice and music are part of what I discuss in the book, and I'll get a little bit, especially to music later on in the talk. But I wanted to take a bigger view and ask about where human sounds fit within the larger soundscape of the world. The frogs and the birds and the insects and all the other creatures that are making sound, both in the present day, but also in the past. How did this great diversity of sound come to be? What function does it serve these animals to sound so different from one another? So I'm going to share a few stories about the soundscapes of the world, starting out with non-human creatures and then moving into to some discussions of our experience of sound. And my method in the book is to visit various locations that I have had the good fortune to be able to visit over the last several years as part of my work, both as a writer and as a professor. Some are places that are from my childhood. As my accent suggests, I didn't grow up here in Georgia. I grew up in France, in Paris, but was born in London, England, to British parents. So some of the stories are from childhood as well, and that's one of the themes of the book, is how we remember sounds and the meanings that they come to have for us. So a variety of different locations, some in the US, some abroad. I'm not going to talk about it so much today. Maybe we could get into it some in the Q&A. There is one a significant location in Georgia, and that's St. Catherine's Island off the coast of Georgia. It's one of the Barrier Islands. Just north of Cumberland Island, if you know that region, just south of Savannah. And it's a place where Sewanee, the university that I've taught at for many years, has a summer program that introduces students to the ecology, the hydrology, the geology, the biology of the Barrier Islands, which of course are enormously important to the ecology and the economy of Georgia, because they protect all the tidal salt marshes and the other places where fish and shrimp and other things that are part of the economy breed. So a little bit of listening on that island. My previous books that were about forests and trees that led to thinking about sounds. And this picture is from the top of a tree in the Amazon rainforest. So this is in eastern Ecuador, very far western part of the Amazon rainforest. And I'm going to play you a recording of what dawn sounds like. Now through Zoom, sometimes these recordings don't sound great, but listen to the different layers of sound here you'll hear. There's some low rumbling sounds. Those are howler monkeys waking up. There are macaws flying over, insects, little songbirds, all giving voice at once. So an extraordinary diversity of sound, and we can actually see that with our eyes as well. So this is a spectrogram, and I'm only going to show 2 of these, so there won't be a lot of graphs and data in the program here. I'll just explain this one. From left to right, you have time. So this is the beginning of the recording on the left, and then we go through about 13 seconds in this graph. And then on the vertical, we have frequency. So, and that relates to our perception of pitch. So at the bottom is low frequency sound, really deep. And then at the top, it's really high pitched sound. So way up, even, in fact, this one goes up to 18 kilohertz, which is way above what I can hear. You know, perhaps when I was a youngster, I could hear that high, but certainly not anymore. And you can see that the dark, the black and the blue and so on, those are the where there's silence. And then the streaks of yellow and red, and that's where there's intense sound. And each one of those marks is a different animal giving its voice. The kind of bands, like someone took a paint roller across there, those are insects giving their buzzing, their trilling. The sweeping sounds of birds going, doo, 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 doo. Then there's a trill. There's some repeated hooting at the bottom there. You can see how crowded this soundscape is. It gets even more crowded at night. So let me play you a sound recorded from the Amazon rainforest at night. And the slide here is the sun is setting. It's not at night, but nearly so. The recording is from like 2 a.m. So we're in pitch black. Insects, high pitched insects. Ooh. And then that hooting sound is a big owl, crested owl, bigger even than our great horned owls here in the U.S. And this is what the spectrum looks like at night. You can see there are these low little dots at the very bottom. There are 2 of them at the beginning and the end of this segment. That's the owl saying, whoa. And then you can see each one of these streaks moving up through here, and these pulsing calls is a different species of insect. And so in 1 hectare of forest, there can be 60,000 different species of insect. Not all of them are singing, but many of them are. And so it's an incredibly noisy place. It can even make your ears ring sometimes. So the Amazon rainforest is a great example of a place where the soundscapes of the world are magnificent, varied, and diverse, and magnificently vigorous as well. Now, it's not just though in the Amazon, we in the southeastern US get to experience this. I mean, right now the birds are moving through in their spring migration. Just this week, I heard black-throated green warblers and Louisiana water thrushes and things, birds that haven't been here for months. They're back. And then in the late summer and the fall, we get the katydids and the cicadas really, I mean, they begin early, but they really reach a crescendo in late summer. And the fall is this extraordinary experience of being in the presence of so many vocalizing creatures. And in these soundscapes, and a soundscape is essentially like a landscape, except through the ears. Landscape, of course, is mostly described as in terms of physical features that we can see. A soundscape is all the various ways in which sound is present, the rhythms, the tempos, the layers, the timbres of sound, all present in a particular place. Within these soundscapes, there is both unity and diversity. And I'm going to talk about the unity first, because I think it's pretty astonishing and it's changed how I listen to the world. And then talk a little bit about some of the reasons why we hear such a wide range of sounds. So first, the unity. All these sound-making creatures, of course, are communicating to one another. And in that communication, they need to hear, they need to perceive the sound. Now, we humans perceive sound through the little hair cells in our inner ears. We can also perceive low frequency sound through our skin. You know, if you're touching a tree or a street railing and a truck goes past, you can feel that sound. You can feel low frequency sounds resonating inside your chest. But the primary mechanism of hearing fine distinctions, particularly in high frequency sounds, is in the coils in our inner ears that have all these little hairs that pick up the movement of sound and then turn that into a nerve signal that goes to the brain. Those same kinds of hairs in a slightly different form, but the cellular structure is exactly the same. These are known as cilia in biology, are found in the leg joints of insects and in little drum-like structures on insect abdomens or at the base of their antennae. The same hairs are found on the surface of fish, on the fish's skin, and also in the inner ears of fish. So any organism that is perceiving sound is using the same cellular structure. A ciliary hair, tiny little hair that is an extension of the inside of a cell. And that hair's job is to convert the motions of the world into the language of the cell, which is chemistry. So when the cell gets moved by a sound wave, or the molecules that are moving back and forth in water or in air, that then causes changes in the internal chemistry of the cells. For single-celled creatures, that might then change their behavior. They might get away from danger or move towards food. For sophisticated, complex organisms like us, those chemical changes in the hair cells and then transmitted to a signal to the nerve cell that goes to the brain, and then through multiple layers of processing in the brain. But at root, it's all the same structure that we're using for hearing. And even more than that, there's more unity than that, because within the vertebrate animals, so fish, amphibians like frogs, birds, mammals like humans and other mammals, if you look at our embryonic development, there's one little patch of cells, and it's a patch of cells that are right here at the base of the brain, between the base of the brain and the top of the spinal cord. During development, those cells then spread out and expand and become the control center that controls sound making. So when I'm speaking, I'm using my breath in relation to my vocal folds, and the cells that were found back here are now the ones that are controlling some of that back in my subconscious, right? They're also the same cells that control the movement of our forelimbs. So when I'm gesticulating, or if I were to be playing a violin or a piano, the sound making is coming from a similar embryological place. So movement and hearing and sound production are all tied up together in these unifying embryological features in vertebrates. If you were to look at how fish produce sound and how they move their front flippers, their pectoral fins, it comes from the same bunch of cells in the back of course, they grow in a fishy way, and the body form is quite different once a fish is developed compared to once a human or a bird or a frog has developed. But back there early in development, there's the same cells. And so when we hear frogs croaking, birds singing, if we put a microphone under the water and listen to the sounds of fish that they make by rubbing muscles on their swim bladders, there are the control centers for that, the nervous control centers, have similar embryological origins, which I think is a marvelous thing, right? As I'm walking around the neighborhood, I'm mostly perceiving differences, right? Birds and frogs and people, we all sound so different and look so different. And yet underneath it, there are these ties. And of course, in biology, we regard those ties as ties of kinship. The reason we and frogs and fish have these similar control mechanisms is because we share a common ancestor. Other people, non-biologists, might have other interpretations of that maybe it's reflecting something about creation, or maybe it's both, right? The kinship from evolution is part of a creative process. So, of course, lots of different opinions about that. The main thing, though, is in terms of the experience of sound, whatever the cause is, underlie it, we have unity in terms of embryology. Now, the Earth was not always so vocal as it is today. In fact, for 9/10 of Earth's history, there's no evidence whatsoever of any sound-making device. So we can look, for example, we know the first creatures to evolve on the planet were bacteria and then single-celled creatures. They can hear sound. They even produce sort of microscopic little hums and are sensitive to them. But as far as we know, they're not communicating to one another. Bacteria don't sing or shout warnings. And then the first evidence we have of complex animals, for the first 200-300 million years of animal evolution, there is no evidence of any sound-making device like you see later on, crabs with scraping devices that make little scratchy file-like sounds, or drum skin-like places, or vocal folds, or structures inside the body that would be making sound. All of these things, later on in the fossil record, we see evidence of them, but not at first. So it seems that the first part of Earth history was lacking in communicative sound. I was about to say it was silent, but that's not true, of course, because there was rain and thunderstorms, all those primal sounds that we can still hear today. I love going to the coast and hearing the waves wash on the sand. That is a sound that has been going on planet Earth for about 4 billion years, ever since the Earth cooled down enough for there to be water and rock and sand. And then the first animals, as they ate things and moved around, they too were making incidental sounds, but they weren't communicative. So what is some of the reason for that, and then the evidence for the first sound? Who were the first sound-making creatures? Well, I think the reason creatures were not making sound is it may have been too dangerous. Every single animal species on this planet that I'm aware of, and presumably all the ancient ones too, had some ability to hear, often low frequency sounds, both in water and then later when animals came onto land. So it was dangerous to stand out there and make a noise. And it was only when creatures evolved the ability to get away quickly and to protect themselves from predators did sound making become possible. And we see this even today. Compare a frog, which is very vocal. The frog has got powerful hind legs. It can get away from predators. Compared to a salamander, also an amphibian, the salamanders are totally silent. And all of their mating displays and things are happening through chemical communication. They release little pheromones and things like that, but they don't sing, because a salamander that stood in the leaf litter in the forest and sang, the turkeys would come and eat it, or all sorts of predators would be all over it. Same thing with worms and jellyfish. They're silent. Mostly, there are a couple of exceptions to that. Whereas things like shrimp and fast-moving fish are often quite noisy. Shrimp can make all sorts of crackling sounds with their claws, are often the dominant sound in many warm waters, including warm waters here in the eastern U.S., southeastern U.S. Okay, so the middle photograph here is an imprint in the rock of a fossilized wing of an insect. It was kind of like a cricket. They're extinct. These creatures lived about 275 million years ago, but they look superficially like modern crickets. And then the top part, the paleontologists, Olivier Betou and his colleagues at the French Natural History Museum, described this structure that has no known function except to make sound. This structure is marked here as SA in the top. They've labeled it, and what it is the wing veins. So every insect has little veins running through its wing, and here they converge and are raised up into a ridge, and that ridge has little bumps on it, almost like knuckles. And so when the wing rubs across that, it makes a burp, burp, a sort of rasping sound. And here's a close-up of that. So this is from the same scientific paper. And here you can see this ridge, how it's raised up from the rest of the wing, has little bumps on it. It's quite small, just a few millimeters long. And what I did was to take measurements from this and then compare them to modern day insects like crickets and katydids, because crickets and katydids make sound in the same way. They have a raised ridge on their wings with lots of little bumps. And when they rub their wings together, it makes that sound. And of course, modern day crickets and katydids often make very pure toned, sweet sounding sounds, particularly the crickets, because the spacing of those little nubs on the ridge is really, really precise. This creature called Permostridulus from 275 million years ago has a bigger ridge and it's more unevenly spaced. So by comparing to modern sound-making creatures, I then inferred what this sound might have been like. And I should emphasize that this is speculative, because we don't know how fast the insect rubbed its wings, exactly how it did it. So this is just the sound recording I'll play here is created from the computer based on the measurements of modern insects, sort of inferring what this sound may have been. And you'll hear it's almost like a frog because it's so low frequency and rough. So the function of this sound, we don't know. Of course, fossils don't record details like the functions of sounds. It could have been a mating call, of course, which is why most crickets and katydids make their sounds today. But it may also have been defensive. So if a predator like a spider or some other creature comes up to this insect and the insect makes a sound, that can frighten the spider away or other predators. And this is true even today. If you pick up a lot of insects, they'll make a buzzing sound that kind of makes you drop it. People have shown with experiments that it does indeed make predators like mice and spiders and things let go of their prey. So the function may have been mating, it may have been defensive, we're not sure. What we do know, though, is that this fossil appears very soon after the evolution of insect wings. And insect wings are special for two different reasons in the evolution of sound. One is that a wing is a great way of making sound. It's this thin, papery surface attached to vibratory muscles that are used for flight. That's basically a loudspeaker. If you take it, like if you've got a loudspeaker in your living room or even in a laptop, I mean, don't do this, but if you take it apart, what you'll see is there's a paper cone with a little electric motor that makes it vibrate. Well, here we have paper wings with not an electric motor, but a motor made out of muscle. So it was great. They evolved for flight, of course, but were soon put to work in making sound. The other thing that wings do is they allow prey to get away from predators. So as soon as this rapid escape mechanism, insect wings, evolved, or very soon afterwards, we have the evolution of the first sound-making insects. And then shortly after that, dozens and dozens of examples of these over the next 100, 200 million years. So when we listen to an insect chorus in the late summer here in the Southeast, we are, in a way, transported back to the first moments of the first primal sounds, animal sounds on Earth. And sometimes I like to think of that as I'm walking through on the city street or through a park and hearing all these insects that can be the dominant sound, that this is a direct sensory connection into deep time on planet Earth. And all the other creatures like the birds and the frogs and the people and so on came later, but for a very, very long time, it was all insects. Those insects then also incentivized the evolution of high frequency hearing in mammals and birds, because about 200 million years ago, you have the first mammals, 150 million years of the first birds, and all around them are these little protein snacks, insects, making sound. And so that probably caused the evolution of high frequency hearing in early vertebrates. The former, that when they first came to land, could only hear very low sounds and couldn't really hear very well at all. Suddenly their food was singing. And so that created an opportunity for the evolution of high frequency hearing. So perhaps we have the insects to thank for the way that we hear the world. So one of the strange things about sound evolution after birds and insects and mammals and frogs all started calling is that they all sound different. Why is that? And for a lot of the book, I puzzle over this question of, if the function, say, of a bird song is just to advertise how strong the bird is or to chase away rivals, then just a simple little croak would suffice. And yet Every single bird has a different song, and some of them are extraordinarily complex and elaborate. Why is that? And they have different pitches and different frequencies. Well, I'm not going to go into all the different possible explanations here, but just share one or two of them from really different time periods to give a little bit of a sense of that. And the first one is that the sounds that animals make have to be adapted to the places where they sing. And so the environment, the physical environment that animals sing in shapes their voices. And a great example of this are the birds that sing in forests compared to birds that sing in open areas like prairies. Birds that sing in forest are putting out their song, and then those sound waves are going to bounce off of leaves and twigs and tree trunks and really quickly get very degraded and smeared and smudged. And you can hear this. If you're in the woods, distant sounds don't sound distinct anymore. They sound all kind of garbled. And in fact, really complex sounds get so garbled we can't even distinguish what the individual notes or the individual words within it. In an open prairie, no problem making that sound. You can make complex sounds and they travel because there's almost no, I mean, there's some grass there, but the birds are singing from song perches or by flying over the prairie. Except for wind turbulence, there's very little to get in the way of it. So birds that nest in forests often have very slow, whistled kind of songs that to human ears sound very melodious. Birds that nest in open country have very rapid back and forth. It's like the end of a sword in a sword fight, going up and down, round and round. I'll play you a couple examples to make this point. And this, it's just two examples, but this is a general truth about bird sounds. Even if you say we're dropped into Australia or Asia or Africa without knowing the names of any of the birds there, if you heard that they were slow and whistly, you could bet that they come from the forest. If they're rapid singing birds, then you know that they're coming from the open prairie. This first sound recording is from Tennessee, from a summer tanager, a bird that nests in the forest. Listen to how melodious and sweet and relatively simple a whistle it's giving. Now let's hear a lark sparrow. This is one I recorded in Colorado. Listen to how much faster this is. So the physical environment leaves its imprint in the voices of birds. In a way, the forest leaves its imprint and lives within the song of the forest birds. The same is true on the coast, particularly birds that live on rocky coasts where there's a lot of waves that make a huge roar. Those birds tend to have very high-pitched, loud calls. They're high-pitched so that all this low-frequency roar, they can sing over the top of that. They can be louder, but also sing at a different pitch, so they can be heard through the tumult of the waves. So again and again, wherever you go, you will find animals whose song has adapted them to the particularities of place. Add on to this the imperative for many of these creatures to display their prowess, their sexual health, their vigor, their ability to find food and defend territories, all the things that go on in signaling in animal communities and within animal species. And you get this enormous elaboration and diversification of sound. The other thing that happens on a much, much longer time scale is that groups of animals that evolved on one continent make it to another continent and then diversify there, bringing with them some of the sort of the vibe or the feel of the original continent, and then evolving it in unique ways in their new home. And I'm going to play in a moment here just two examples. One is from forests in Tennessee, and one is from Australia, from forests in Australia. And these are forests that are about the same latitude, so about the same distance from the equator. course, the Tennessee ones are north of the equator, the Australian ones are south of the equator. But you'll hear the sound of the birds is totally different. So let me, so the first sound you'll hear is from Queensland, Australia, followed by Sewanee, Tennessee. And listen for just the overall feel of the bird songs that you're going to get. Tennessee. So I hope you can hear the difference then. Why is this? Well, it turns out songbirds first evolved in Australia, then they moved to Asia. And the songbirds that we have here in the US are mostly came over in two waves, one about 30 million years ago, one about 18 million years ago, two waves of migration that then diversified into the warblers and the New World blackbirds and the vireos, orioles and things. They're the birds that we're familiar with and that are common in forests and backyards all over the US. This is a subset of Asian birds that are a subset of Australian birds. So you go to Australia and you hear a much wider range of vocalizations because essentially it's the original birthplace of songbirds and also of parrots, making whip-like sounds and wailing and twittering and all kinds of, a whole range of different sounds. The birds that we hear in the forests here are generally from 2 or 3 different bird families that have found their niches here in the Americas and diversified in their own ways and bring their own acoustic imprint. Now, when a bird lover goes between continents, they can immediately hear the difference because the birds don't jump between continents very often. We're hearing the legacy of ancient migrations from one place to another. However, if you were to go and listen to the crickets in different continents, they sound really similar. Why is that? It's because crickets are really good at jumping from one continent to the other. Some get caught in storms and hurricanes and just blown across the Atlantic. Others land on a piece of seaweed or a dead log that washes out to sea and then winds up on another continent. If there are a couple of crickets on it, or even just one cricket who's ready to lay her eggs because she's already mated, immediately that new continent is colonized. And so there's more of a uniformity in cricket sounds because they're really good continent hoppers. Birds, not so much. We're hearing the legacy of more ancient migrations. So when we listen to the birds and the insects around us, we're hearing both how they adapt to their present day environments, but also the story of their migration among continents. So it's really a convergence of different timescales. Now, where do people fit into this bigger story? And I'm going to, music and language are some of the more magnificent sonic productions in the world. Where do we fit? Well, I'm going to start by talking about the origins of instrumental music. So music played with instruments. And one of the amazing places I was able to visit when researching this book are caves in what is now the south of Germany. And these are caves where some of the first modern humans first arrived in what we now call Europe. So they came up presumably through the Middle East, where there are more ancient archaeological remains of humans, and then before that from Africa. And this was during the Ice Age, so it was pretty tough life living there. I mean, so Germany these days, of course, isn't all covered in ice and snow. These people were living essentially on what we would now call the tundra. And then the tundra was mostly frozen over for a good chunk of the year, and north of them and south of them were great glaciers and mountain ranges. What did they do with the highest form of their technology, which back then was stone tools? They made musical instruments. And these caves in southern Germany are the places where as they excavate down through the layers of detritus in the bottom of the cave, they've got to a layer 42,000 years old where they found flutes like this. These are flutes made from the wing bones of vultures and of swans, big birds, of course, with long wingspans, and with hollow bones, as most birds have hollow bones. All it takes to convert this into a flute is some ingenuity, some understanding of the flow of air, and some finger holes. And that's what people did here. They also took the ivory from mammoths, so woolly mammoths or other species of mammoth as well, particularly in the US. These were the European ones. And they carved out of those big ivory tusks, they carved flutes from that. And the one you see here is a replica made from mammoth ivory, actually, that was dug from an archaeological site. And Wolf Hein, who is a specialist who works, he's based in Germany. He's a specialist who's worked with museums all over the world in recreating Paleolithic and other ancient human art forms and technologies for museums and other people who want to investigate and share the early story of humans on this planet. So he made this flute using the tools that Paleolithic people would have done 42,000 years ago. And then Anna Potenkowski, who is a flute player also based in Germany, then played this flute to try and understand what sort of sounds it could make. And I'll play an example here. So what you're hearing is an almost exact replica of these first known instruments anywhere on planet Earth being played by a modern musician, Anna Fredrika Potenkowski. So imagine being in a cave in the Ice Age and suddenly hearing this incredible music reverberating around the inside of the cave. A really kind of magical experience, particularly when you think, oh, how are you playing the flute? You're using your breath, which most religions understand the breath as sacred. It's the origin of the word spirit is the breath. So the breath of a hunter is flowing into the remains of the prey and bringing beauty and, in a way, new life back into that prey. And that new life is music that then draws people in the human community together. So a really extraordinary, powerful experience. And it's an experience that derives from the human body in intimate relationship with the materiality and ecology of other beings, in this case, mammoth ivory or swan wing bones. But it's true even today. When you hear someone playing a violin or a piano or a guitar, you're hearing the second voice of the forest, because the human body is in relation with trees and wood and even plastic. Plastic is just made out of oil, and the oil was made out of ancient algae that were buried in the bottom of the oceans. That's what geologists do. They go and find those. One of the things they do, they find those oil deposits. And then, so when we're playing a plastic keyboard, we're in touch with these ancient life forms as well. So all instrumental music, even though we might hide this dependence and interconnection in the rituals that we produce around music, is actually like going back into the woods or going back into the ocean and placing our senses into intimate relationship back with the materials of other beings. And one of my hopes is that in this time of ecological change and ecological crisis, we can remember that human music is not just human music. It's humans in relation to the living world, the rest of the living world. And from that, we produce beauty. And we should remember that beauty then entails responsibility to care for the world from which we derive such extraordinary beauty. So human instrumental music draws us into community. The other thing I want to talk about in terms of human, the human experience of sound, I'm going to skip over these slides for the moment, is to talk about human sonic memory. So I think many of you may have had the experience of hearing a sound from your childhood and immediately being transported back to that childhood. This is one of those sounds for me. If you look at this slide at the top, here's a European blackbird sitting on a chimney in a courtyard in Paris. And when I was a kid, we lived in one of these, lived in an apartment like this. And the sound of the blackbird would reverberate, would echo within this courtyard. And to this day, when I hear it, I'm transported back. And so here's a little recording, and you'll hear how the blackbird uses the courtyard as a reverberant space. So it turns out we humans have really good acoustic memory compared to chimpanzees, gorillas, monkeys. Birds have pretty good acoustic memory as well. But why do we have such incredible memory that over a span of like 50 years, we can remember a sound that we may not have heard in decades and decades? For me, it was this bird sound. That it might be a word or the particular texture and timbre of a loved one's voice, or a word in a foreign language that we haven't heard in a long time. We remember it across the decades. Why is that? Well, humans, of course, are a linguistic species. We've been speaking to one another as long as we've been humans, and probably before that. There's evidence from genetics that we may have been able to speak for at least the last half of a million years before we were even Homo sapiens, when we were more other Homo species that came before modern humans could most likely speak. And therefore we have this great memory because it serves us well to connect one to another. But it also can serve as a way of connecting us to the ecology of our homes. And I think this is particularly important now when we live in a time of rapid change, that if we're not paying attention in the present moment, what stories will we have to tell to kids, grandkids, friends, neighbors in the future? And I think that we think of listening to bird song and insects and things like that as sort of a pleasurable thing to do when we're relaxed and so on. But I think it's more than that. It's a foundation for our culture to get back in touch with the more than human world, with the living earth community. Now, I've studied birds and bird populations for quite a few decades as a researcher and also as a teacher. But the one thing I remember the most about birds, the one piece of data or information that I recall the most, is what my grandfather told me. He grew up in the northwest of England back in the 1920s, 30s. And he told me that this was back in the 70s and 80s, 1970s and 80s, that the birds that he heard now in the countryside were just a tiny fraction of what was around when he was a kid. And so obviously I wasn't around in the 1920s or 30s, but he transferred that memory to me. And he could only do that because he was paying attention. When he was younger, he was paying attention to the world around him, and then could retain that memory to then pass it on through the generations. And we don't have to be young to do this. We can remember things that we heard decades ago, or we can pay attention in the present moment. And so my invitation to you is to think about how you might like this spring and summer to expand your listening out into the world. And it may be learning a few bird songs, or appreciating the insects in the world around you, or perhaps it's going to some musical concerts and then listening for the song behind the instruments, where these instruments came from, and how they're uniting with human artistry and human creativity to create these moments of shared connection in the present time. Because I think that the glorious diversity of sound on Earth is worth protecting. It's threatened by human noise and the way we're silencing many ecosystems. And we will only realize and be able to protect it if we're paying attention. So one of my hopes for the book is to share the delights of listening with people, to encourage deeper listening in the present moment. So I think I will close, and I'd be delighted to take any questions or comments that you have, and be happy to go into any of those points that I'd raised.
Great. Thank you so much. I see some questions coming on in, but as you were speaking, I was thinking of one experience that I had that I think would be very helpful for others maybe to enjoy is oftentimes the symphony will have their performance at a park or
Mhm.
at a zoo. And so that you do have that a little bit of a connection with nature and that sound of music. And I think it's really enjoyable and a great way to connect with
Mhm.
nature.
Absolutely, yes. So any music that is taking place in a space with other species singing is always opportunities for listening for those cross connections that are really marvelous.
Right. So one of our questions is, we are admirers of the work of Bernie Krause, which is what led us to pick up your book. Thank you for this fascinating and important work. We will be listening more intently in our daily walk.
Thank you. Yes, and for those who don't know, Bernie Krause wrote The Great Animal Orchestra, a marvelous book about sound, and particularly the threats that sound faces. And he also has been very influential in people's thinking about sound, and that he's proposed this idea that through ecology and evolution, animals divide up the acoustic space. So some sing high, some sing low. I'm simplifying a great deal here, and they don't overlap in time in order to for each species to be heard. And his argument is that some of that synchrony and some of that harmonization, if you like, or spreading out of frequencies is being damaged by human actions as we modify ecosystems. And we hear this, of course, most clearly in places where habitat has been completely removed. And of course, there's a massive simplification of the soundscape.
And to follow up with that, the same attendee asked, can you talk about research around whale song?
Yeah, so one of the chapters in this book is about the oceans. And I think the oceans are a place where the acoustic crisis is the worst, because shipping noise and seismic exploration for oil and sonar from some ships really is creating a cacophony that stops many marine mammals, but also fish and invertebrates like shrimp and other things more at the base of the food chain from communicating to one another, and actually does physiological harm to them. So I think we do face a great moral challenge, and that is, how can we have a thriving human economy without pumping so much sound into the oceans? Because whales and some of their cousins, the dolphins and other marine mammals, are some of the most acoustically sophisticated creatures in the world, with very complex songs and things we might think of as languages. You know, the use of the word language, of course, is controversial. Some people like to use it for other species and others not. And yet we're creating an acoustic hell for them. So I do think there are two pressing challenges, and one more pressing than the other. The first is reducing noise pollution in the oceans, and the second is deepening our appreciation for the subtleties of sound. And in the book, I talk a fair amount about noise pollution and what we could do about it and what people are doing about it, and also get through some specific examples into some of the sophistication of whale communication. I mean, they don't just have one sound, they have cultures where each within a population, you can have different dialects and different matrilines where youngsters are learning their song and their accent and the meanings of their sounds from their mothers and grandmothers. So marine mammal society, acoustic society is extremely complex. And yes, so excellent point to raise.
Thank you. And I know in your book, you talked about the effects of the pandemic and the lockdowns and the effects that sounds have. Can you speak of that briefly?
Yeah, so the lockdowns made, for some people, it made them more aware of the sounds that are around us, because of course traffic noise went way down, and for at least some people, they were at home with time on their hands. Of course, for a lot of people, the workload just went way up, and they weren't at home sort of listening to the bird song. But for at least some people, there was this sense of greater awareness of the sounds around us. And non-human creatures also responded. There's a great study by Elizabeth Derryberry and her colleagues who've been studying sparrows out in California. And around San Francisco, they found that the minute the lockdown happened, the traffic noise went way down, and the birds in the city changed how they sang within weeks to reoccupy that space, the acoustic space, the frequencies that had been taken up with traffic noise. So birds are really listening, very sensitive to their environments, and are finding ways of fitting their voices in. And then now the traffic noise has come back, presumably the birds are squeezed back into a narrower range. So yes, there are studies on whales. Some of the whale studies haven't been published yet, but to show a similar kind of effect, that there was a decrease in stress hormones in the whales, not just with this lockdown, but when 9/11 happened and a lot of shipping stopped. There was a study of stress hormones that showed there's a huge drop in the stress level in the whales because shipping noise ended, and so they weren't so swimming around in anxiety and dread the whole time.
Yeah, that's very fascinating. And I'm assuming the birds would have the effect as well because the planes weren't flying perhaps during the lockdown.
Yeah, I mean, for birds, if you're near airports, that is definitely an issue. During the lockdown, it was mostly traffic noise, which is the major source of noise pollution. And I should point out that noise pollution isn't just blocking the songs, it's actually stressing out the body. So even nestling birds near a noisy road show premature signs of aging. And the same is true of people. And this becomes an environmental justice issue, is that when we locate busy highways through particular neighborhoods, and in the US, it's mostly been through Black and low-income neighborhoods, not through wealthy white neighborhoods. That noise pollution isn't just an inconvenience or an annoyance, it actually increases rates of heart disease, because even when you're used to the traffic noise, it's increasing your blood pressure and your stress level, and so it produces physiological effects as well. So there's been a lot of research on birds and insects and frogs, but I think it's important to remember that we are acoustic creatures too, and that the noise levels that we impose on other people are part of the question of how should we live? And so I think with city engineering, but also personal decisions, like how much noise do I want to be making with my yard equipment and things like that, is an issue that is directly affecting people's health in a very direct way.
Right. And we have two questions, and I think they kind of intertwine with what you were just talking about. One of them is, can you talk a bit more about how climate change is impacting soundscapes?
Yeah, so I think the major effect of climate change is through changes on soundscape. It's through vegetation change. So for example, in Colorado, where I lived for 3 years, when a forest fire comes through and burns 200,000 acres of forest in one summer, and then that forest doesn't grow back for 20 or 30 years because it just got burned down to rock, the soundscape is completely transformed. Most of the animals that were there before are gone. And that is happening in tropical forests as well, as climate change is changing forests and prairies and other habitats all around the world. So in a way, it's an indirect effect, because climate change then changes the forest, and then the sounds are made by the creatures who live in the forest. But there's another effect, and particularly in the oceans, a lot of the sounds of the oceans are from waves and from polar ice cracking and from wind playing on the surface of the water. Those sounds are also changed by climate change, as is, sound actually travels a little faster in warmer water. So there are all these subtle changes that may have a big effect on the soundscape and on living creatures, or they may not. It's not so clear with the changes in water. On land, changes in forest and habitat, huge changes. And in fact, that's, I think, one of the main drivers of changes in soundscape is loss of forest, loss of complex forest in some parts of the world.
Thank you. There's a few more questions. This attendee is asking, I'm interested in binaural and healing sounds. Do you have a connection with healing tones and the sounds of nature you observe?
Yes. So I should say somewhere on my website, there's actually a series of binaural recordings. So binaural sounds are those recorded with microphones at an exact distance from one another. So when you listen with headphones, it sounds like you're right there. So that they're tuned for hearing with two ears. And there are various ways of making those recordings. And I have a collection of binaural sounds of water and people kind of merging in different ways. It's been a sort of side project of mine that I put out as a CD when CDs existed. Now it's mostly an electronic thing that's out there for free now. And healing sounds, so that there are two ways in which I think of healing sounds. One are healing tones. So say bathing, going in a group session or individually to bathe in particular tones to create a particular mental space and physical space. And there's good evidence that really can help at least some people as a form of meditation and coming back into the presence of the body in a way that most of our lives doesn't encourage. We got our cell phones going at us and then noise from left, right, and center and all around. The healing tones bring us back to center. The other way, and this is actually something I do a lot more of, is going out into a little patch of woodland or a park in the city, or even just walking on a city street and doing a sound walk where you just walk without judging the sound. Like often there are some kind of sounds that I really don't like really loud trucks or, leaf blowers, particularly if they've been going for more than like an hour and they're still at it. But on a sound walk, and, other people have other things that sort of get on their nerves. On the sound walk, it's like you're just bathing in the sounds and you're walking through it and you just let go of judgment. So again, it's kind of meditative. And some of them will be things that sometimes we would find unpleasant, but many of them, I never noticed how the wind sounds different in a pine tree and a maple tree. Or I never understood how the sounds of human footsteps are so totally different depending on how people are walking. Are they feeling angry, or are they, walking gently, or what kind of shoes they're wearing? There's a whole music of human footsteps out there that we can go and enjoy as a sound walk. So and of course in the woodland you get to hear all the birds and the other non-human creatures, which most people find very relaxing. But we can do it even in like a train station or an airport if we get into the right frame of mind. And admittedly, at a train station or airport, it's a little harder to kind of let go of all judgment. But that's a practice. Just stick with it and sort of be in the sound. And then, when the walk is over, we'll go back to our usual selves again, perhaps transformed just a little bit by the sounds we've heard.
So are there any apps that you could recommend that can help identify sounds or a particular bird song or?
Yeah, so I mean, one app, the primary app is going out with other human beings. That's the way we've been doing it hundreds of thousands of years, finding local nature groups, other groups who are organizing time outside. So that's one way. The other way, particularly with bird sounds, is there's an app called Merlin, MERLIN, like the wizard or the bird. There's also a bird called Merlin. It's an app put out by the Cornell Lab of Ornithology, and it does a lot of things. One of the buttons it has on it allows you to it will identify bird songs for you. And it's not perfect. I mean, I've tested it here in Georgia, and I'd say it's like 95% of the time it's right, maybe even more than 95% of the time. I'm just pulling it up here so I can show you how, and it's a free app, and you open it up and then it will say start bird ID. And then there's this button called sound ID. So I'm going to press that, and there's a little microphone, and it gives me a real-time spectrogram of what all the sounds. And, I'm in the dining room here. There are no birds. So it's not pulling anything out, but if a cardinal or a crow or a prairie warbler showed up and was singing, it would pull it right out. And I'm really impressed by that app. And the goal is we use the app for a while, and then we don't need it anymore because we know what a cardinal sounds like. And maybe we pull it out when we hear some weird bird we haven't heard before. So it's really useful. And I know a lot of people have really found it to be helpful in their listening practice.
Great, thank you. We have time for our last question. This one is, what is the first thing you do when you want to isolate a sound in any given environment?
Okay, if I'm just by myself and not trying to record, it's a matter of attention, right? You get closer to the sound or as close as you can without freaking out the creature that's singing, and then just focus. I think of it as sending tentacles out of the ears to wrap around that sound and draw my attention to it. For sound recording, there are a couple of ways of doing this. The classic way is with a parabolic reflector, which is kind of like a satellite dish with a microphone in it. And it's highly directional. And there are microphones also called shotgun microphones that you point it directly at a sound source and it only records what's coming from exactly that direction. All the other sounds it ignores. So that's how most ornithologists record and focus in on particular birds. That's part of it. The other part is just sort of field technique, is being able to be like a hunter, be quiet and move without freaking things out and getting closer to the sound source. Don't ever look directly at the bird or the other creature. Don't move suddenly. Those kind of things can help, even when technology isn't going to help. And often when I'm out and about, I have a little sound recorder. It's a tiny little one, because if I don't want to carry a parabolic reflector around with me the whole time, kind of huge and cumbersome, I bring it out for like special occasions. So with the sound recorder, it actually trains you to be better in the field about sneaking up on things and being careful about finding low noise environments. So those are a couple of approaches that I've used.
Great. Thank you so much, David, for sharing all your information and this wonderful and engaging talk. Those of you who haven't had an opportunity, please check out Sounds Wild and Broken here at the Gwinnett County Public Library or your favorite library or bookstore. It's highly recommended. And again, we thank you all for joining us. And thank you, David, for taking time out of your schedule to speak with our community.
I'm delighted to be with you. It's a real pleasure. I wish you all good listening this spring.